So this question wants us to rewrite this weird looking expression in terms of x and y only. It is a composition of trig functions and inverse trig functions. So the idea is to remember what inverse trig functions really stand for. So this first expression here, sine inverse of x, we have to remember equals some angle. I don't know what that angle is because it uses variables, it doesn't use numbers. So let's just call it theta. But I do know something about this angle. ST stands for such that. I do know that this whole guy equals theta such that the sine of that angle is x. Now, typically when we think of trig ratios, we think of fractions, so you can always make a non-fraction into a fraction by putting it over 1. So the same thing for the cosine inverse of y. I know that the cosine inverse of y is going to be some angle. I don't know what exactly that angle is because we're using variables, so let's just give it a symbol, call it theta, phi. What do I know about this phi? I know for a fact that the cosine of this phi should equal y as a fraction, y over 1. Now, the idea in this unit, which was the same as the idea in Unit 6, which was the same idea in Unit 5, is the moment you have trig ratios, and these guys certainly are trig ratios, you can always draw a triangle. So if we were to draw a right triangle with the angle theta labeled somewhere, I can guarantee you, according to this information, that the sine of that angle, the opposite over hypotenuse, is x over 1. And now, of course, we can use Pythagoras' theorem to figure out the missing side. This missing side is going to be the square root of 1 minus x squared, just straight up Pythagoras' theorem. We can do the same thing for the angle phi. If you were to draw a right triangle with angle phi labeled somewhere, you can guarantee, according to this information, that the cosine of this angle adjacent over hypotenuse is y over 1. And then, of course, through Pythagoras' theorem, the missing side length is the square root of 1 minus y squared. So, if we were to go back to the actual question, this question is basically saying, is asking, what is tangent of theta plus phi, where theta and phi follow all this information? Well, this is nothing more than what? Tangent of a sum. And we should, according to our reference sheet, know what tangent of a sum is. According to our reference sheet, tangent of some angle plus another angle is tangent of the first angle plus tangent of the second angle all over 1 minus tangent of the first angle times tangent of the second angle. So to actually figure out what these values are, just read the pictures, right? If you have a complete triangle, you should be able to figure out any trig ratio you want, even if you don't have numbers, because it's just SOHCAHTOA, opposite, adjacent, hypotenuse. So let's go ahead and do that. So according to my picture, tangent of theta, opposite over adjacent, is x over the square root of 1 minus x squared, plus tangent of phi, opposite over adjacent, is the square root of 1 minus y squared over y, all over 1 minus those two guys multiplied together. Notice that we do have a compound fraction, so you have to simplify this compound fraction. This was not one of the options on the test. The way I like to do it is by clearing the fraction. So I'm going to multiply the entire numerator and then the entire denominator by the LCD. Hopefully we can see that the LCD are just these two pieces put together, right? Because they're the same. They're the common factors. So the LCD is simply y times the square root of 1 minus x squared. So if we were to multiply that guy out to the first term, the radical 1 minus x squares would cancel, leaving us with x times y. Plus, if you multiply this guy out to the second term, just the y's cancel, leaving us with the two radicals multiplied together. 1 minus y squared, I guess I'll show my work, times square root of 1 minus x squared, all over. If you distribute this guy to the 1, it's just itself. Y square root of 1 minus x squared minus, and then if you distribute this to the last term, everything cancels. The entire denominator cancels out, so you're just left with the original numerators. So you're left with x radical 1 minus y squared. And I believe, in terms of the choices, that was it. They didn't choose to rationalize this because it's pretty messy. But I do believe that they went ahead and squished these guys together. Since it's two radicals multiplying each other, according to the properties of radicals, you can just squish them together as one giant radical. So I think this was an option on the exam, but that's basically it. The main idea is if they give you inverse trig function, it just stands for an angle. But the important thing is that the sine, cosine, tangent, depending on whatever inverse trig function you're given, the sine, cosine, tangent of that angle should equal the original input. Right. So this simply means sine of theta equals x. This simply means cosine of what I call phi is equal to y. There you go. That's the solution.